So, uh, last time we talked about the different types of variables, and we talked about a marginal distribution, which is where we look at the totals. We also have a conditional distribution. Okay, and so since it's a two-way table, we have two variables, right? In this case, age and cell phone. And so I believe that we looked at the conditional distribution here for cell phone type by age. All right, and so we were looking at the number of iPhone users out of 18 to 34-year-olds. Okay, well, you can also, each two-way table has two conditional distributions. All right, so there are two sets of conditional distributions for any two-way table, one for the column and one for the row. So let's look at the conditional distribution of age, given the fact that it is an iPhone. Okay, so in this case, we are just looking at the iPhones. Okay, so how many 18 to 34-year-olds in the survey had iPhones? Look back at the table there. $169 people, yes? And how many total iPhone users were there? 467. Okay, and so let's write that as a percentage, which is approximately 36.2. Okay, so look back at the table. How many 35 to 54-year-olds were using an iPhone? Okay, 171 out of the total. The total doesn't change in this case. So this is 467, which is approximately, let's say, 36.6. And then the 55 plus, we've got 127 out of 467, which is 27.2. Let me do one more here and then I will let you finish the table. Okay. So the conditional distribution of age, given the fact that it has to be an Android. Okay, so we're just looking at the Android users. So how many 18 to 34 users had an Android? Look back at the table. That was 214. And total number of Android users was, let me look back, 503. Right, so that is approximately 42.5%. So go ahead and finish the table for me. If you have not, do that for me. Okay, so check your numbers with mine. And make sure that they match up. There. Okay, so again, difference. Conditional distribution, there's two, because there are two categorical variables, one for the row, one for the column. Marginal distribution, we are looking at the totals there. All right, so let's go down here and answer this last question. It says, based on the data, can we conclude that the age of a person plays a part in the type of cell phone they have? Draw a side-by-side bar graph and compare the cell phone types among the different ages. All right, so you might need a different color of pen or pencil here, if you have one. If not, you can designate it in another way. Just a second. So we're gonna do like a side-by-side bar graph. And these are the percentages. And then I am going to do the ages on the x-axis. And so I am going to designate the different categories of phone by color. Right, so I'm gonna do iPhone here. And then Android. And color. Okay, if you want, if you don't have a different color, you can make slash marks across there or across something like that to designate the different types of phone. Okay, so now we're gonna do a side by side. So looking at these, the 18 to 34 for the iPhone was approximately 36.2%. So it might look something like that. And then the Android, the Android was 41.4%. I'm going off the top table there by the top conditional distribution. So I'm looking at this right here. Okay. Because this is by the ages. All right. So this one was 41.4 and the other was 25.9. So let me change colors. So that it looks something like that. Okay, and so go ahead and complete the other bars for the 35 to 54. And then the 55 plus. And I will do that as well. Okay, and so take a look at that. For a second. And what do you notice? What, I guess my question is, what's the advantage of having a graph?
It's easier to pick out, like,
Got it?
sorry, it's easier to pick out like, which ones are more or less.
Right, you can see immediately, like, look right here. You can look at the percentages, right, and tell, but looking at the graph, you can see immediately that when the survey was taken, the people in the 55 plus had different types of phones other than an iPhone and an Android. Okay, so let's answer the question that he asked. All right, it says draw a side-by-side bar graph to compare the cell phone types among the different ages. And then it says, based on the data, can we conclude that the age of the person plays a part in the type of cell phone that they have? Okay, so here's what I said. Based on the sample data. More than one half of the (18 to 34) and 35 to 54 users have an iPhone or Android. And so I also said, okay, looking at the red bars there, younger users tend to prefer Androids slightly, maybe. So younger. And to prefer. Let me go up there. Tend to prefer Androids. While older users had a slight preference for iPhones. Okay, and so we're gonna use the same data and do one more thing. Okay, look at one more time. Okay, this, for obvious reasons, is called a side-by-side bar graph because each of the categories has its own bar. We also have what is called a segmented bar graph. Okay, and so part F says we could also use a segmented bar graph to compare the distribution of ages and cell phone types. Draw the segmented bar graph and discuss which graph makes the comparison easier. Okay, so we're still gonna put the same variables on our X and Y axis. All right, so let's do that. This is the percentage. Scale it. Remember I told you it is really important to always scale and label your graph. And here we're gonna put the ages. So we've got 18 to 34, 35 to 54, and then 55 plus. And so in a segmented bar graph, we have a total percentage of 100. But again, we're going to break it down by the different types of phones, and then we're going to put that percentage within each of the category. So for example, right here, we have 32.7%. And then for the androids, looking back, the androids for the 18 to the 34 was 41.4. So I've got 41.4 and 32.7. That's right around, let's see, 74%. So I'm gonna do that and then put 41.4. And then for the other. Use green. And that was. Let's see, it was 25.20. 27.2. Sorry, it's 25.9. Looking at the wrong one. Okay, so this is called a segmented bar graph, where it has each of the categories filling out the percentages there of 100 and broken down by the corresponding percentages. Okay, and so go ahead and do the other two ages. And I will as well. So it might look something like that. And so the question is, discuss which graph makes the comparison easier. And I think the answer to that is it depends on what you're looking at or what you are comparing. So the segmented bar graph has some advantages, right? Looking at the total of 100% there, but then also the side-by-side bar graph also has some advantages if you're trying to compare the two categories, okay, quickly. So I would say. Let me change colors there. It depends. If you are comparing. Both graphs have certain advantages. And so finally, it says, we say there is an association between two variables if knowing the value of one variable helps predict the value of the other. If knowing the value of one variable does not help you predict the value of the other, then we say there is no association between the variables. And that language that we use is very important. Okay, we say there is an association between the two variables. So based on the graphs, can we say that there is an association between age and cell phone type? Probably so, I would say. I would say there seems to be. An association. The older a person is, the less likely they are to use an iPhone. I'm gonna scroll up there, to use an iPhone or Android. Okay. Any questions for me? I got one more thing to do, okay, but before we do that, let's take a little stats break, all right? So let's go stand up for me, stretch a little bit. All right, here we go, last thing. Okay, so we looked at side by side bar graph. We looked at segmented bar graph, which has each of the three categories of phones on top of each other in one bar, and the total is 100. And we're gonna look at mosaic plots, last thing here. Okay, it says Yellowstone National Park staff surveyed a random sample of 1,526 winter visitors to the park. They asked each person whether he or she belonged to an environmental club like the Sierra Club. Respondents were also asked whether they owned, rented, or had never used a snowmobile. Okay, here is a two-way table summarizing the results. Okay, quick little survey, first period stats. Anybody ever ridden a snowmobile? Raise your hand. Raise them high. It's kind of fun, right? Last Christmas, we went to New Mexico and that was the thing that we did. So one big thing, right? We got all our winter coats on and went up on the mountain and went snowmobiling, really fun. Okay, so it says compare the distributions of snowmobile use for Yellowstone National Park visitors who are environmental club members and those who are not environmental club members. We've got a side-by-side bar graph, a segmented bar graph, and what is called a mosaic plot. A mosaic plot is a modified segmented bar graph in which the width of each rectangle is proportional to the number of individuals in the corresponding category. Okay, so let's look at these. All right. We've got a side-by-side bar graph right here. This is side-by-side. All right, we've got a segmented. And then we have what's called a mosaic plot, which is a type of segmented bar graph. But what they're saying is the width of each of the bars corresponds to the other categorical variable, okay, the percentages. All right. And so we've got the segmented bar graph there, and then we've got own, rent, never are the three colors, but then notice right here, we've got the no's, and the yeses. And so the width of each of those bars corresponds, okay, to the percentages here. Okay, so how many people are no's? It was 1,221 out of the total. Okay, what percentage is that? Can somebody give me that percentage quickly? Tammy, you get it?
80%.
Okay, so roughly, let's say roughly 80%. So this is, the yeses are gonna be roughly 20%. Okay, and so now what they're saying, okay, so look, if we're looking on the x-axis here, and we are going from this point to this point, those percentages are proportional. All right, and so the no's from right here to right here, that would be approximately 80% of the axis there. That makes sense? And then the yeses would be 20%. Okay, so let me say something. All right, if we are looking at these on the AP exam, for example, I'm guessing, I don't know what's on the exam, of course, but most likely they're probably going to give you a graph like this and then ask you to interpret it. Okay, rather than constructing it. All right, so it might be a multiple choice question. It could be a free response, right? Where they give you the graph and then they're going to ask you some questions about interpreting it. All right, so we're going to do one quick little practice there. Here, turn the page. Let's look at this. Okay, body image. A random sample of 1,200 US college students was asked, what is your perception of your own body? Do you feel that you are overweight, underweight, or about right? The two-way table summarizes the data on perceived body image by gender. Okay, so we have those three categories for the body image, and then it is broken down by male and female, and then we have the totals. So part A says, of the respondents who felt that their body weight was about right, what proportion were females? Okay, so we are looking at the about right, which is that right there. So the question asks, what proportion were females? So that's 560 out of a total of 855. And so that percentage, somebody want to help me out? Okay. 65.5%. Okay, next, it says of the female respondents, what percent felt that their body weight was about right? So this time we are just looking at the females. All right, so I'm looking at the column here. All right, so the about right was 560 out of the total number of females, which was 760. And that is 73.7%, something like that. And then the last question here, they give you a mosaic plot. Right, and the advantage of the mosaic plot is it lets you see a graph that is proportional to one of the categorical variables there. It says the mosaic plot displays the distribution of perceived body image by gender. Describe what this graph reveals about the association between these two variables for the 1,200 college students in the sample. Okay, so this is what I said here. Based on the mosaic plot, there is an association between perceived body image and gender. And so I'm going to explain that in just a second, but I want you to look at the mosaic plot. Why would I say that it seems like there is an association? What's one reason that I could say? Tell me, please. Michael, what do you say?
Female college students seem to be perceive themselves to be underweight less often.
Okay, so another way to say that, right? Males, it looks like probably 4 times as likely to perceive themselves as underweight. Okay, yes? Okay. So let me answer the question that they asked. Is there association? It seems like it. And now I'm gonna provide my justification for that. Okay, so I said males are about 4 times as likely as females to perceive they are underweight. Males are also less likely to perceive they are overweight. But one last thing, all right, let me look at the last category, and I said, but the majority of both genders feel their body image is about right.